Solve the system by substitution or elimination. If the system is inconsistent or has dependent equations, say so. Here we have the system, which contains the equations 12x minus 5y is equal to 8, and 3x is equal to 5/4 y plus 2. I'm going to choose to solve this system by substitution because in our second equation here we have x almost solved for. It's almost isolated. So let's start with the second equation and multiplying everything through by 1/3 in order to isolate x. 1/3 times 3x is x. 1/3 times 5/4 y is 5/12 y, plus 1/3 times 2 is 2/3. So I'm going to denote these as equations 1, and let's call this equation 2. Now we'll substitute our value for equation 2 in for x in equation 1. Here we go. So equation 1 becomes 12 times. In place of x, we'll put 5/12 y plus 2/3 minus 5y is equal to 8. Now let's solve this equation for y. Distributing up front, 12 times 5/12 y is 5y, plus 12 times 2/3. 3 goes into 12 4 times. 4 times that 2 is 8. Minus 5y is equal to 8. Now notice something happens here with our y terms. Positive 5y, negative 5y cancel out, leaving us with a true statement. 8 is equal to 8. That is true. So what's happened here is our two equations are actually different forms of the same equation. If we graphed them, we would see the same line sitting on top of itself. So we would say then that these equations are dependent. Let's make a note of that. They are dependent equations, and let's write the form of our solution set. The solution set then consists of all points x, y that take the form of, we can write either of our lines. I'm going to write that first form, 12x minus 5y is equal to 8. So we have dependent equations and a solution set, all x, y, such that they satisfy the equation 12x minus 5y is equal to 8.